Hello, so here's my midterm submission for track one. And so I created a project called College Football Predictor. So the purpose of this is I trained a couple of machine learning models on how to predict college football outcomes. And so I had a couple ideas in mind. I know that in college football, home field advantage is a big factor. Um, and there's just a large talent disparity in college football, and I just love watching it. So that's kind of where the project idea came from. And so I needed a data set for that. And so I found this website, collegefootballdata.com. Originally, I was going to use Kaggle, but then I found out this data set had more accurate data and included more years. So I went with this. So if we head into my code, I created a scraping script. I pulled the data between 2022 and the current year, and then I saved that into my data folder. It was raw as a CSV, and it contained every game between 2022 and now. And then I needed to clean this data. So I filtered the seasons between the current year and now. Uh, and then I determined the winner of the match. So if the home team won, and meaning that they had more points, we would add that to the column. So this is just preparing my data set so that I could get to here where we have a pretty clean system. The original data set contained ELO. And so this would become super important for me, calculating ELO and yeah, the home win. But yeah, here's just me cleaning up the data set. We also had to fill missing ELO ratings because some teams wouldn't contain that. And then we also wanted to filter out teams that had a value of home conference that was like invalid. So we wanted to pull teams that were FBS only. And then we're going to save that clean data set. And then I also created another table called upcoming 2025 games. And so I wanted to save this so that I could then compare um, the outcomes to upcoming games as well. And then I also saved um, our current 2025 outcomes. So I wanted to be able to train the data on the seasons of 22 to 24 and then see how well my model is trained and compare and then have it predict the season 2025. And then I can compare because right now we're currently halfway through the season. So we do that. And now we're able to enter into our models. So originally I started off with random forest. And so we created our target variable, which is home win, of course, because we're trying to determine who won. And it's just a binary output right now where we're not worrying about calculating scores. I added the feature for home field advantage. Then we also added a feature for the home conference because we wanted to, in college football, there's a huge disparity between specific conferences. So I wanted to factor that in as well. And then we're also using the home team's ELO, the away team's ELO, if it's a neutral site match, and then home field advantage as well. We want to fill in those missing ELO systems. And then now we want to split our data by season. So we want to train it on 22, 23, and 24, and then we're going to predict it on the season 2025. So we assign our X training set. And then one thing that I wanted to add was weighting by season because a team that played really well in 2022 could have fallen off. And so I don't want to weigh season's performance 3 years ago to their performance last year. So I have a simple scale. So 22 um, season games, we want to weight at 1, 40% higher for 2023 games, and then 70% higher for 2024 games. And then we set up our model. and then we fit it, and then we predict y values, and then then the model would be trained. And so I got some interesting outcomes with this. So I created a utility file. Oh, and it would save the predictions into CSV for that model. And so I made it a couple utility files where I could just analyze the performance of the model. So here I am set up to analyze the how the random forest performed. So we calculate my accuracy, util.accuracy, accuracy.py. My computer's a little slow. Well, it's very slow. There we go, and you'll see we had a predicted accuracy of 59%. And then I thought this is interesting. How about let's compare conferences and see how well the model could calculate conferences. So here I have a couple conferences placed in the American, the Athletic Coastal Conference, and we're going to plot them with some different colors just so it's nice to look at. And then we'll compare their predicted wins versus the actual, and then we'll compute that accuracy. Um, and then we're going to display the teams and their total games played and then their combined accuracy. And then we're just going to plot this. So if we do that, here we get a nice little chart. So it predicted the Mountain West Conference matches the best with an 84% accuracy, SEC the second best, Big Ten. This doesn't surprise me. SEC and Big Ten, I would expect to be very accurate because these are some of the best teams. And so in the beginning of the season so far, most of their matches have been against lower tier opponents. I also made an FBS compare, which does virtually the same thing. It's just it prints it. So, and we can analyze some of the extra data provided about each model. So here's how it analyzed the Sun Belt, the SEC, so at 78% accuracy. And then this is one of the really cool scripts is teamcompare.py. And here we can enter in a team and it'll analyze and or it'll print to us their schedule and then if we predicted that specific game correctly or not, and then it'll also print the accuracy of that match or of their season so far. So here I'll print that. Team compare. And here we just printed Indiana's season. And we can see our model was 85% accurate when predicting Indiana matches. So it predicted Old Dominion correctly. All the matches we'd expect, except for in real life, actually, Indiana beat Oregon, and that was an upset. So it's unsurprising that our model got that incorrect, but nothing to worry. Still very good accuracy. And then we also trained a logistic regression model. So same thing as before, we created our target variable. It's virtually the same, at least for the initial setup. We had to split our data set the same way, assign weights in the same exact way. I was just interested to see how logistic regression performed compared to random forest. And so we trained that model. So now if I go into my accuracy, actually here, let's go to conference compare. And let's run it with regression. You can see it did exceptional. Predicted SEC with 87% accuracy, predicted Big Ten with 83% accuracy, Big Ten was 73. So our logistic regression model performed far better than the random forest one. Here, let's do team compare. Let's pass in, let's do, hmm, how about Alabama? Let's see how Alabama did. Util team compare. Oops. Oh, I affected something. That's what I did. Commented out the wrong thing. All right, yeah, let's check Alabama. I thought three. Util team compare. And we calculated a couple games wrong. So Florida State, that was a huge upset, so unsurprising. Got the rest correct. Georgia, that was a toss-up match, and then these two correct. So pretty interesting. It was really fun making this project. Yeah, that's basically it. So we trained our two models. We cleaned our data sets. We had a couple scripts for evaluating our model and its results. The codes were reproducible and it's clean. Yeah, that's the project. Thank you so much for watching.